Okay, thank you. So thank you for the grandfather, but just knowing that you made a miscalculation in your number, it's 26.96. There was one digit that you made wrong, so put it on your slide, my grandfather. And according to Luke Skywalker, I would say I'm your father, right? Okay, thank you very much for having me. Thomas, thank you for giving us a stage. You know, Christian and me, we always said we would kill for an audience, and finally we have audience. So thank you, everybody, for having us here. And my challenge today is to give you a 20 minutes talk about our activities. And there's a rule in theater, never put children or animals on the stage because they will outperform you. And I brought you today our spot here, and I brought you something else which is on my hand. And these are the two topics that I will today talk about. The title itself, it's not so complicated. It's about communication. And why is communication important? Everybody who is here, you like robotics, right? Yeah, but there's something, if you as a human want to engage with robotics, there's something needed, and this is communication. And we have a long history how we communicate with data, Netflix, Facebook, whatsoever. But communicating from a human to a machine, totally different thing. So I will talk about mainly two projects. One of them you see on my head is CETI. It's an excellence cluster for the tactile internet. You can go over there and you can learn about it. The idea is, how do you democratize access to skills and expertise? The internet engaged us with information, but now what you can do is you can bring your expertise to a machine. You don't have to program. You might say, I stole the idea from Christian and Wandelbots, the no-code robotics. But that is what we are in Dresden are all about. We would like to enable humans to program and interact with machines. The other project is 6G Live. It's a new project, and whoever knows me, I was never a great fan of the term 6G, but there were 70 million reasons why we should do that project. And now we are thinking about new kind of communications with machines, integrating sensoric actuators together with communication, for example. So I will always come back to these two names, CETI and 6G Live, because I think that is something that we are doing here if you want to go over and have more information. But let's go back to communication. Maybe some of you have heard about this term 5G, right? It's not over, even though we talk about 6G. Who of you have already a 5G-enabled phone here? A few. You shouldn't, because it does not give you any advantage at the moment, right? And when we talk about 5G, that means we have more generations. The first 4 generations were for the consumer market, not interesting for us. 5G is different. 5G is the communication with the Internet of Things, with cyber-physical systems. And that is something we always wanted to have. If you want to communicate with that, there's something in this communication that 5G would give us, which is there's a definition of a triangle. On the top, you have multimedia. On the left, you have IoT. But on the right bottom corner, there's something named latency. And everybody who knows about latency knows the way we interact with systems, everything is defined by latency. And latency in communication, there's a basic rule. The basic rule tells you you can never improve a system afterwards. Once it is defined, you will see that is your system. Bandwidth and data rate, you can plug money into your system and it becomes better. Latency, not so much. And why is latency so important? I brought you here a very old example where we had cyber-physical systems that were cars or mobile robots that are going over an intersection. And the better the latency is, the more cars you can put on the street. So the question for you is, how do you engage with your robotics? How is the latency in 5G? And on the left, you see some curves. There were different versions of 5G. What you have on your phone, I thought you raised the hand, is a non-standalone 5G system, which is nothing more than 4G. And I would guess that every robot here in this hall will not run on 5G with non-standalone. Standalone is a new word where you then have a real 5G core back network, what they are now implementing. So there's hope for your device, right? And then you see we are half in the latency, but we are not there yet. We need even more advancement in the latency to make this interaction very efficient. When we talk about 5G, the good news, and maybe you have seen it yesterday here, you have also 5G campus solutions. These are private networks where you can interact with your robotic system, with your cyber-physical system on your private ground. You don't need the networks of network operators. The good news is, and therefore most people engage in campus networks, that the campus networks will keep the data inside its own campus. And this kind of security is a big feature. And that enables us, as you can see here, to bring 5G wherever we want to have it. We have a lot of projects from the university side, together with Wandelbots. They bring the robotic expertise, and what we are doing is we are bringing the connectivity. And then you have very nice interactive possibilities. Here, for example, you see Merve with a glove. What this glove has to do with that, I will show you in a minute. Currently, what is also interesting in communication, that everything is software. We are going away from specialized hardware, and everything that you will see is pure software. And software is not only important for robotics with one platform, as Christian said, it's very important also for our communication system. The solutions in 5G, there's one big mistake currently, and something that you will also face if you would like to deal with this and engage, and that is the price tags. And currently there are some ideas how to reduce the price by having specialized software or by combining it with something that you already know, which is a Wi-Fi technology. Current Wi-Fi systems are very bad for latency, but they become better because they have learned some lesson that listen before talk is not the right answer. So when we talk about 5G on the cellular system, there will be also new releases, right? Sorry that I have to give you these numbers, but release 15 is something that we have currently, and it's hard to engage with the robotic systems. With release 16, that is really coming in a few months, you will see that the latency will become very good, especially for our friend here for spot communicating. And we are making more and more of these releases, getting the latency down. And here's a problem now. Latencies, they're not anymore in the link, in the wireless link. Now the latency is in the software. It's in the components, in the computing. So it's your task, if you find solutions, to not increase the latency, because then it's harder to engage with the system. There are other things how 5G, for example, will be brought to you, especially in rural areas. There's something called high-altitude platforms, satellites, for example, or what we do with Deutsche Telekom. These are these kind of airplanes in the height of 20 kilometers that will then fly over Germany and bring you 5G connectivity. So there's an overall view about how you can really communicate with your robot and with your cyber-physical system. If you might have heard about an initiative, it's called 5G ASIR, and they have a way how we will communicate with robots. And there are different architectures. What you see here on the left is the classical standard way of doing it, right? You would just have in your cloud system something to control the robots over the whole 5G network. But as I said before, latency-wise, that's not the optimal thing. Better would be to have the software pushed towards your system as a mobile edge cloud or network function to bring it inside your network. Then the latency goes down. And there are other initiatives, for example, communicating not over a base station with the robot, but having direct communication between the robots. So that will be release 18, 19, where you get really the possibility to communicate directly between the environment and sensors and the robot. So this is very helpful. And the last picture, what you see here, maybe in the end you don't need any network at all. You really have the direct power from your controller directly to the robot. So that was all about 5G. But you have heard about, there's a term of 6G. While 5G is really communicating towards the machine, In our definition, we say 6G is about communicating humans and machines. And therefore, I have this glove. This glove is very important to understand my motion, my behavior. So in this project that we have in the Excellence Cluster, we started years back, and there was also Christian and Maria and Georg, and we all thought about how can humans engage with the machine. And what you see here on the right, that is Mr. T. On the left is Tim Höttges, CEO of Deutsche Telekom. And we only wanted to mimic every movement of a human to a humanoid robot, right? Still, it was a masterpiece by the Pichniks and Georg to bring this thing to life. So that was the starting point. But then the idea of Wandelbots and also what we do in SETI is just get the expert and don't let him go the thing like talking to a computer scientist and let him program the robot software. We thought about let's cut out the middleman because computer scientists don't like to talk to you. So therefore, you see here the whole chain of an expert repeating over and over again a certain skill set. And this we will then bring with machine learning into software that we can run on a machine. But the first task is to understand the human behavior. So I brought you a video here of Merve. She has this kind of glove for mimetic. The stand is over there if you want to hear it. And you see that she's moving the hand, and all this movement is then transported into the digital world. But you can also steer and control machines with this directly. So when you see, I hope you can see it over here, there are some lights on it. If I move some of the fingers, I hope the right lights go on, right? You can see it here, also here, and here. So the reason this amount of data that you will see here is so tremendous that it will kill your delay, because also the pure amount of data can have an impact on the latency. So we have to understand already on the glove which of this information is important and which is not, right? Another demo, when you have just the movement of the hand, what can you do with that? A very easy task is, are we doing the right stuff? So here we are assembling something, and step by step, by looking at my movements, you can see whether you're doing the right step. Are you using the right tools? So my dream is, for every IKEA wardrobe, you get a glove. And then it will tell you, go back to page 17, you did something wrong, right? Because there's always something in IKEA that does not work. So last but not least, and therefore also Spot is here, you see how you can interact with cyber-physical systems, right? We did not do it here today because our 5G container is not there anymore, but now it's very easy to control it. The control currently is done, where's Justus? Justus here with the remote control. But most people having such a device, they don't know how to steer the Xbox controller. And we were asked by Boston Dynamics and the partners, can you train people to just tell to the dog, go straight, come here, right? It's, for example, smelling gas in some fabrics and so on. So this interaction is very important. But the glove can do more than that. It's not just monitoring it. Inside SETI, we have people from psychology telling us that humans are predictable. You would say, I knew that humans are predictable. But for example, if you are standing in front of a table with 30 different items, and you want to grab one of the 30 items, we could know this half a second, sometimes even a second, before you actually grab it. Just by forming your hand, how you start the movement, we can see it. What this is, you might say it's prediction. It's more than prediction. We call this negative latency. And we do a lot of tricks in technology to get the latency down. But if we could predict humans, then we would have something what we call negative thing, and it gives us some decision space to get this, some new solutions here. So this is what we call 6G, right? And it's not only the task of communication. I think you understand that. It's about the actuators. It's about the sensors. And inside SETI, we have this very nice arrangement of research. So there are 12 different research rooms. we call them virtual research rooms. Not because of COVID. These virtual rooms are layered. On the top, you see our use cases. We think about medicine. Also, one example is here. Industry 4.0, or the way how we learn in the future. Then you see on the bottom all the expertise you need. On TP1, that means there are psychology people telling us about the needs for people, for latency, for feelings, for touch. And the other TPs are doing the same. It's not only about getting the information from the glove. The glove should become also an actuator, giving you a tactile and haptic feedback. So all of that, you can see there are over 60 people now, and some people call CT nothing else than the research department of Wandelbots. But what we are really doing is we are trying to engage on a global system. What you can see here, teaching a robot in proximity, that's nice, but we would like to do it on a global scale as the internet is doing it. So in this kind of rooms, we are producing some kind of startups. A lot of startups will also talk here today. You can see them. You can go over them and learn about them. Two of them are not here, which is Mesmerize and Campus Genius. These people are more in the connectivity area. Last but not least, let me just combine the idea of senses, of multimodal feedback, and the need for a new communication system. That's a little bit more technical. But what you see here, on the left, you have the expert, and on the right, you have the machine. And in order to communicate, you cannot use the standard internet. The standard internet currently has something or provides something that is called net neutrality. You might say, what's wrong with neutrality? Switzerland is neutral, that's good. So we should also have something that is neutral. But when it is neutral, means that all the packets in the network are treated in the same way. But if you think about video or audio or haptic feedbacks, they are totally different from the bandwidth requirements and the latency. So actually, just for these three senses, you would need 3 different networks. The good news is that you don't need really physically 3 different networks. There is a new feature inside the upcoming communication networks, which is called network slicing. So you can create logical networks inside a physical network. And these slices, as you can see them there, these slices provide you with different characteristics in terms of latency and bandwidth. And when we talk about the senses, for example, video has high bandwidth, but you need latency around 15 milliseconds. I learned as a student, maybe 100 or 200 milliseconds would be enough. But the psychology people tell us 15 milliseconds must be the response time that you don't get seasick. Audio signals 3 milliseconds, and the data rate is around some couple of kilobits. And haptic is interesting. If you have haptic signals, not only the movement, but also if you want to give something back, if a material is stiff or not, that from the latency requirements is the hardest. It's only 1 millisecond that you have. But from the bandwidth, nobody knows. The amount of data is tremendous, but there might be also some kind of codec to compress the information. This is something what we are currently doing in our research and trying to find it out to build such a system. So with that, I'm coming to an end. Again, thank you for having us. Audience is really good to have, and I'm looking forward to meet you here next year. Thank you very much.